This is problem 11.6 from Brigham and Houston, Fundamentals of Financial Management, concise 9th edition. And here we're asked to take Project A and Project B and calculate net present values, that's capital NPVs, assuming that the weighted average cost of capital is either 5%, 10%, or 15%. So I'm going to calculate these just using the data that's up here in the spreadsheet. At 5%, 10%, and 15%. Now there's an NPV function in Excel. That's a little n, little p, little v. So the NPV function in Excel calculates what we call uneven cash, the present value of uneven cash flows, and it's NPV, little n, little p, little v, open parens, discount rate, which in project analysis is the weighted average cost of capital, comma, and then the cash flows from period 1 through n. Okay, so that's the present value of cash flows here, here, and here. The capital NPV in finance is the present value of the future cash flows from periods 1 through n minus the initial outlay. And the initial outlay is the cash flow at time 0. Alright, so to solve for this equals NPV, open parens. I'm going to use this discount rate, comma, these cash flows from periods 1, 2, and 3. I'm going to lock out, I lock the row for the discount rate. I lock the column when solving for the NPV of the future cash flows. And then I want to add this negative cash flow at time 0. And so what it's doing, it's plus a minus number because the cash flow here is minus. So the function NPV F4, comma, C5 to E5 gives me the present value of these cash flows. And then when I add the negative initial outlay, that's essentially giving me this function here. Alright, so when I copy this to these other areas, because I'm using cell references and absolute cell references, I can, if you set up the spreadsheet the correct way, one of the calculations you can use over and over, or you can just copy it to the other cells. Alright, so these are the PVs, the NPVs for 5, 10, and 15%. And notice that at the 5%, Project A is higher, but at 10%, Project B is higher, and at 15%, Project B is still higher, but both of them are negative. If we're going to calculate the IRR is fairly simple. Equals IRR, and then cover up all the cash flows from period 0 through 3. Alright, and add a decimal place or two. What that's saying is that Project A is earning 11.1%, Project B is earning 13.2%. Okay, so that's part A was the NPVs. Part B is the IRRs. All right, if the weighted average cost of capital was 5%, which is our set here, and A and B were mutually exclusive, meaning I can have one or the other, but I can't have both, which project would you choose? I'd choose the one with the higher net present value, because what that means is that I'm earning a total dollar amount that's higher based on the return that I'm earning plus how much I'm investing. Now, if the weighted, and in part B, if the weighted average cost of capital was 10%, I would choose B because it has the higher NPV. And then for C, I wouldn't choose either of them. It gives you a hint, the crossover rate at 7.81%. 7.81% is the interest rate that caused the present value, the net present value of this one and this one to both be identical. So if I change that to, actually just copy it out over here. If I use 7.81%, notice they have the identical net present value, and then I wouldn't choose, I'd flip a coin between them. The NPV rule is better than the IRR rule because while you're only earning 11.1%, you're earning it on more money here. So 11.1% earned on a $25 investment generates more return than a 13% investment earned on less money. Which would you rather earn, 1% of a million or 20% of $100? So that's why we use the NPV rule. It pays attention to not only the rate you're earning, but how much you're earning it on. The IRR rule simply measures the rate you're earning. And again, I would rather earn 1% on $1 million than 10% on $100.